Morning, everyone. We're gonna give it another 2 minutes to just let people slowly work their way in. Then we'll start it up. All right, I think that's a good enough amount of time to let everyone come in. So first of all, good morning, everyone. Thanks for joining us for our topic on just an overview of humidification. With us is our friend Ronnie with Neptronic. He's our Odell and Regional Sales Manager. He'll be conducting this meeting today, or this presentation. Just come with housekeeping items. If there are any questions, there's a Q&A or a chat off to the side. Feel free to send it in there, and then I'll interject as Ronnie's talking along, and we'll either get to the question right away or near the end of the presentation, because there will be Q&A at the end of the presentation as well. And also, this presentation we'll have PDH credit hours applied to it as if needed. So Anna Marie will be taking attendance here, and if you will be receiving those within 1 week of the presentation today. So without further ado, and thanks again, Ronnie, take it over.
Thank you, Mike. Good morning, everyone. Thank you for joining. So I'll jump directly in sharing my screen. And as Mike said, there's like you guys can ask questions via messages, or you can even at some point, if you have a question, you can just stop me and it will be my pleasure to answer you. So today, the idea about this presentation is really to give you an overview about the humidification, what type of products usually are available for which application, what consideration you need to take when you're designing the humidification job. So since I don't know what's the level of each of you on the humidification, so I'll not go in deep details. It's really an overview about, design and the product that are available. So typically why we need to humidify. Mostly if you look at the humidity itself, the whole year, you have not a lot of variation. It will always be between 50 to 70, 80%. So it's not a big deal. The big problem is really on temperature wise. That's where we have the bigger swings. So in summer, it's hot. In winter, it gets really cold, especially in this area of the world. So that's typically where we need the humidity. And as you may already know, we always design with relative humidity. It's always relative to the temperature. And that's why we always need to humidify in winter. Because if we look at relative humidity, even if it's 80% outside in winter, but it's only 30 degrees Fahrenheit, as soon as we heat the air from 30 to 70 Fahrenheit, now our 80%, it's only 18%. Because the more the air is heated, the more it can retain moisture. And that's why by heating the air gets a bigger capacity to retain moisture, and that's why we always need to inject humidity, mostly in winter. So what type of application do we look at when we want to design a humidification job? I would say every application should have a humidification unit in it, like museum libraries. If you want to preserve the quality of the arts, the quality of the books, the papers, the floor wood, office, hotels, and schools, mostly for the indoor air quality, which I'll touch base in my next slide. Data center, clean rooms. Now, data centers are booming all over the world, and that's mostly what are making us really busy in the past couple of years, really selling for the data centers job, which also I'll touch base in a couple of slides for you, just to give you an idea what type of products mostly they are using data centers. Pharma application, labs, hospitals, healthcare, printing industry, tobacco industry, agriculture industry, any type of industry will require some sort of humidification, which we'll touch base in the coming slides. So usually, I believe if you had any humidification presentation from any supplier, you've seen this chart. That's called the Sterling chart. It will tell you most of the time you always need to be between 30 and 60% relative humidity. So below 30, you'll have problem developing viruses, bacteria, allergies. Higher than 60, you'll have different problems like fungi, mites, all these type of stuff. But when COVID hit in 2020, there was a lot of studies done to understand, okay, what's exactly the correlation between indoor air quality and virus, and how we can mitigate viruses by improving indoor air quality. And the finding were, if it's a dry in the air, the virus can float up to 41 hours in the space. As you can see, usually the virus is really small. It's like we're talking about 1 to half microns of diameter. But if you inject enough humidity, the virus will come and catch these humidity and they will inflate, like a small bubble will get more moisture in it, will inflate. So instead of being half microns, it will go up to 100 microns. And by being bigger, it's heavier. So now it can drop on the ground in 6 seconds instead of floating for 41 hours. And since it's bigger now, it's way harder to infiltrate someone else's body through the nose or the throat or the ears. So based on these findings, the 30 minimum 30% that I showed you in the Sterling chart does not stand anymore. Now, based on these findings, we need to be around 45% at minimum all the time. By having 45%, we have way better chances to control the bacteria and the viruses inside an office, inside the room, inside the hospital, inside the school. And that's why since COVID, there was a lot of school renovation, including humidification, to try and mitigate the virus and bacteria. So that being said, if you want to design a humidification job, where should you start? At first, you need to know, okay, what's the design condition? How much you want to maintain inside the building you're designing, and what's your outside condition, which is like in which area you're designing it. You need to know, are we dealing with natural ventilation? Mostly I still see that in churches and stuff, like, there's no office building with natural ventilation, but some churches still have it. So we need to know that. If it's a mechanical, do we know how much CFM are we getting from the outside? What's the total CFM? And if we have an economizer mode, that also can change a lot. So we need to know all these information. Now, after that, we need to know what's the distribution. Okay, where are we gonna push the humidity? Is it directly in the space? Is it inside the duct or inside the air handling unit? We would need to know the dimension of the duct or the air handling unit, and we need to know what's the distance available after the grid before we hit any other component inside your system. So the distance between the grid or the filter, the duct, a turning vane, a cooling coil, that's what we call the absorption distance. So we need to make sure that all the steam going out of the grid are absorbed before they hit another component and create condensation, which we don't want to. So that's mostly the basic information everyone needs to have before starting designing a humidification job. Also, a very important point that a lot of engineers don't consider when designing is you need to know what's your water quality. How bad or how good is the water quality you're dealing with in the area where you're designing your system, because that can affect a lot how the unit or how your whole system will operate. So if you're using city water and you know that the water is fine, it's not too hard, then you can just do all your design based on your city water. But if you know that the water is very hard, let's say I think in Toronto you guys have almost the same water as us in Montreal, so it's not that bad. But let's say you're designing a job in Calgary or you're designing with well water, usually it's very hard. And in this case, you always need to consider the water treatment, even a water softener, reverse osmosis system, or DI system. To be honest, no one uses the DI system in humidification unless they have it already on site, because it's expensive and you don't need that much pure water. So RO should be your best bet. If the customer doesn't want to go with RO because it's more expensive, at least consider water softener, because you need at least to treat the water if your water is higher than 7 to 8 grain of hardness. So anything more than 7 to 8 grain of hardness, we start talking about hard water. And why it's a problem? Because if it's a hard water, you're boiling it, you'll end up with a lot of scale inside your tank. So that's why you always need to know the water quality you're dealing with. Also, we need to know what type of energy source you'll be using. Is it electricity, gas, the steam, an existing boiler, or you want to go with evaporative stuff? So that's mostly what you need to do to start designing a job. That's just a picture I took from a job site to show you how bad can hard water be inside the tank. Like this, that's a job that was taken in Alberta, and it can get that bad inside the tank if you're not treated your water after a couple months or a couple of years of operation. So when you're designing a job, you have always two options. Even you go isothermal, so you're just injecting steam in your space, so you're using an external source of energy, even gas, electricity, or the boiler steam. Or you can go adiabatic, which you are injecting humidity, but at the same time, you are cooling down the temperature at the same time. So adiabatic, as you may notice, since you're cooling, you will not be using it on every single job, because in winter, most of the time, you don't need to cool unless you're doing specific application like data center where you need cooling all the time, printing industries where you have a lot of printers generating heat all the time, or you can use it for other application that's not really dedicated only to humidification, which I'll mention it in a couple slides. So in isothermal, most what's available on the market is these options. So you can go with electric humidifier, gas fired, steam to steam, or direct steam. When I said direct steam, that means you have an existing boiler already in the building and you're just taking the steam out of this boiler and you are injecting it in the space. On the diabatic side, you can go with the high pressure system and or the evaporative humidifiers, which we will touch base on each option. So electric humidifiers. You have two options to design with. You can go with electrode or resistive. What's electrode? As you can see here, electrode, it comes in plastic cylinders, white plastic cylinders, and it works with conductivity. So for this type of technology, the only water that you should be using is the city water, because this unit works with conductivity. So you can't use RO or DI because it's pure water. There's no conductivity in it, so the unit will not operate. And this unit always works by building up enough minerals in the tank and start giving you steam. So the downside of this unit, you don't get precision out of it. You're always fluctuating plus minus 10% the whole time because the unit is always trying to drain, refill, build up enough scale, enough conductivity to start giving you steam. Where is it a good application? These units are good for comfort humidification. So for a human being, he will not feel the difference between plus minus 5-10% humidity. But if you're doing a pharmaceutical application or a precise application where you need to be always around 40%, that's not a good application. Also, this one may be a good application if you have really clean water and the soft water around. Because if you have very hard water, what will happen? These electrodes will scale up very quickly. And there's no way to clean these up. So you need to take them out, throw the whole plastic cylinder, put a new one in. So on the long run, it will cost a lot of maintenance on these units if your water is not good. But let's say you have a decent water, 4, 5, 6 grain of hardness, you're using it for comfort application, it's not a bad option. The second option you have, it's a resistive application. So which means you have, as you can see here, you have heating element that's heating the water to get the steam out of it. And as you can see, most of the products, when you go with resistive, it's not a plastic cylinder that you throw out. It's a stainless steel tank that you need to clean. So the big difference in here is that you can use any type of water because you are using your heating element to boil steam. So you don't care if there's conductivity or no. So you can go with city water, RO, DI, water softener. There's no issue here. Plus, on the long run, it costs less on the maintenance because you're not throwing away these plastic cylinders. You're just cleaning the tank. And if you have a decent water, you will need to clean the tank once a year. And if you put an RO before the unit, then you barely need to clean it at all. So that's the advantage of going resistive. Also, the biggest advantage is the precision that you can get out of resistive. Because if, let's say, you're designing a job, a lab job, where you always need to be plus minus 35, plus minus 40%, you should always go resistive because these elements will modulate by SCR, so they will always give you exactly the capacity you need. But keep in mind, and that's really important, even if your water is not that bad, if you want precision plus minus 1%, you always need an RO system before the humidifier. And why is that? Because usually, if you're using city water, whoever the brand you're using, your unit will go through drain cycle every 4 to 6 hours, depends how you program it. Why? Because every time we're using city water, we want to dilute the scale inside the tank so you don't end up with a lot of scaling, as I showed you in a couple of pictures before. So automatically the unit will stop working to go through a full drain cycle, refill up, boil the water again, start giving you steam. So during this period, you lost your set point, so you're not plus minus 1% all the time. Now, if you go with our O system, you don't need to go through drain cycles every 4 to 6 hours because we know it's pure water. So we tell the unit, don't drain, just keep running the whole time. And that's how you can achieve your precision out of it. So keep in mind, if you're designing any precision electric humidifier, you always need to have an RO before the unit, have resistive unit with SCR control, and definitely you need to also have a humidistat that can be precise. Because I've seen some engineer designing stuff around, but they end up with like, a range of humidistat that cannot give you precision. So it's really the whole system should be designed for precision, not just the unit itself. The second options you have is gas humidifiers. So when we go gas, mostly in Ontario, there we are still using a lot of gas because gas is, I believe, is less expensive than electricity, and people are still going gas. But at some point, gas will slowly start going down because like everyone wants to go more green and they're pushing more on electricity, but still gas, it's still a big chunk of the business. So when you go with gas, mostly it's because even gas is cheaper in the area you're designing, or you have big capacities and you don't have enough amperage in the building to cover it with electricity. So on the gas side, you can have the option to have the unit indoors or outdoors. I actually, in most brands, will have all the options indoor outdoors, not just gas. Even electric, you can have it indoor outdoors, or steam to steam, you can have it indoor outdoors. But I see most of the time gas unit outdoors, mainly because usually gas are more bulky. So if you don't have enough space in the mechanical room, you can put it on the roof. And by putting it on the roof, you save on building a chimney for the unit because you don't need a chimney. So that's where we see mostly gas unit outside. Now, the big question is it safe to have a gas unit outside in cold weather? Yes, because depending on the manufacturer, everyone has its own protection to make sure that if you lose power at some point during winter, you don't freeze your unit. So everyone, depending on who you are designing with, has his own way to protect the unit. Most of them is gonna be normally open valve. So if you lose the electricity, you will drain your whole system. Some of them will have heaters inside the enclosure, so you're always heating the tank so you don't freeze it. Some others will keep the water inside your tank at a higher temperature, even if you don't need the humidification. So it heat the whole enclosure, and you definitely need to heat trace every single component that's outside the unit. So anything coming from the roof to the unit should be always heat traced. The third option you have is the steam to steam. So usually we used to sell a lot of those in hospitals because hospitals, they have always boilers. But in the past years, boilers had a lot of chemicals inside of them, and you don't want to inject these chemicals directly into space. So what they do, they will take the steam from the boiler, they will pass it through the steam heat exchanger here, and then fill this tank with fresh water, get it heated by the steam in the heat exchanger, and you get clean steam out of it. So some people will call it clean steam humidifier. Some people will call it steam to steam humidifier. It's the same. The idea is that you're using the dirty steam from the boiler to get clean steam out of this unit. Now, keep in mind, this unit operates at a maximum of 15 psi. So you can't use the pressure steam coming from the boiler directly on this unit. You need to have a PRV station to get the pressure down to 15 psi before connecting it to this unit. Another option, if you decide that the steam inside the boiler is clean enough, then what you can do is really use the steam from the boiler and push it directly through the grid system without using any generator. That's what we call direct steam application. So in this case, you will only need a float, a temperature sensor, a steam separator, and a steam valve. And then you connect directly to your grid and you push your steam directly there. Again, maximum pressure on this application is 15 psi, so you can go from 5 psi to 15 psi. You can't go higher than that. So make sure also to have a pressure relief valve to get your pressure down to 15 psi. So that's mostly the equipment you need when you go with direct steam. Now on the distribution side. So until now, I spoke about generators. So that's where you boil your water to get the steam. Now you need to connect this generator to a grid. You have two options, even a single tube, which is called here a SAM, a single absorption manifold, or a multi-steam. So multi-steam, you'll have multi-tubing with one big header where the steam will connect to this header. So your steam will go up, the condensation from the header goes down, and then you trap. Actually, it's not showing in this picture, but you have like a drain below the header, so you can take the drain back even to a drain next to the unit, or you can actually take it back to the unit itself. So what you do, if you have enough slope for the drain coming from your grid, you can take it back to the generator and reboil it again and send it back to your system. So I would say 90% of commercial application will go with multi-steam. Some smaller application where you don't have a lot of capacity, you can just use a single tube in the duct and you'll be fine. Now you have the option to have single row tubes or double row tubes, depending again on the manufacturer you're using. It can vary, but why the idea I'm showing this slide is that for you to be aware that when you're designing a job, it's really important to know the absorption distance you have. So as I mentioned earlier in my presentation, that's the distance between your grid and the next item that it's gonna touch. So whatever it is, a filter and a coil, we need to know this distance. So let's say you have 4 feet. That's perfect. You don't need a lot of tubes. You'll be fine. But let's say you have only 8 inches or 1 feet or even sometimes 6 inches. The only way for any manufacturer to give you that low of absorption distance is by adding more tubes. So that's why you may see double row tubing. So we add more tubes to shrink the absorption distance and make you fit inside your design. Now, keep in mind, and I'll show it in a couple of slides, it's not always good to have a very small absorption distance if it's not needed. And what I mean by that is, years ago, engineers were used always to say, I need 6 inches or 8 inches absorption distance, because in their mind, even if I have more, let's say 6 inches, at least we are safe. We don't have to worry about any absorption, any steam being condensing. The issue when you tell us when we're designing a job that you have a really small absorption distance, but in reality you don't, it will affect the cost as a first cost, and it will affect also the cost running the system, which I'll show you in 2 slides. Also, you have an option, which I always recommend to engineers when you are stacking jobs, to always specify insulated grid. Why it's important? Because by insulating the grid, you will save a lot on condensation loss. And condensation loss, that's where the big saving in humidification is. Because what's condensation loss? That's water that you paid energy into it to make it steam, run it through the grid, it get cooled by the airflow and then condensed back. So that's a total waste of money. So by insulating the grid, you will save a lot of condensation loss, and that means a lot of energy and a lot of money on energy. Each manufacturer has its own way to insulate. So you can have a PVDF insulation, and then you encapsulate that with stainless steel. So you can go up to 85% efficiency on insulation, which is a huge. Some others will just have a PVDF without stainless steel. Some others will have double wall stainless steel without the PVDF. So it really depends. But to be honest, based on my experience, if I can recommend you something, try always to specify a company that has a double wall stainless steel insulation. Why? Because if you are not protecting your insulation with stainless steel at the end, with time, if you have water dripping from the nozzles on the insulation and you have it into your airflow, the insulation itself will dry off, and by water dropping in it, it will perforate your insulation, and after a couple of years, the insulation will start deteriorating and flying into your airstream. So ideally, you want a company, a brand that when they insulate, they have a stainless steel insulation somewhere to protect the insulation. So let me give you this example just to explain to you the importance of insulation and the importance of absorption distance. So let's say you have 20,000 CFM unit, 50% makeup air, dimension of the unit, outside conditions, indoor conditions, the load. We know that based on these conditions, we need 240 pounds unit. Also, I forgot to mention, actually, yes, I do recommend always insulating the grids for any job higher than 100 pounds per hour. Because if you have 20 pound per hour job, it's not bad to insulate. You always have an advantage, but the saving you're going to make on energy will not cover the cost you're paying extra for the insulation as a first cost. To be honest, usually below 100 pounds per hour, the energy you're wasting is not that big because you don't have enough steam running to lose that much energy. So to justify the cost of adding insulation versus the cost of saving on energy, it's not worth it. But any job higher than 100 pounds, that's where it starts making sense. So let's hit this job very quickly. So let's say you have, in reality, you have 36 absorption distance. And for me to give you 36 absorption distance, I need to give you a grid with 14 tube. So I'll have a header with, with 6 tube. So I'll have a header with 6 tube, and I'll be condensing 12 pounds per hour. So the real load will be 252 instead of 240, and I'll be adding 0.76 Fahrenheit of heat gain, which I need to cool down at some point. Now, if I take the same job, but I insulate my grid, so at 36 inches, I still need 6 tubes, but now instead of condensing 12 pounds per hour, I'm condensing only 1.8 pounds per hour. And that's, again, I know, this presentation is not sales, so I'm not mentioning brands, but what I'm showing you here, I mean, it's obvious coming from our side. So the 1.8, that's 85%. Every company has a different efficiency on their insulation, but even if it's less than us, it's still worse to have insulation. But here it's based really on the 85% efficiency. So 12 pounds instead of 1.8 pounds. So you're not adding much of a loss, and you're just adding 0.11 Fahrenheit heat gain versus 0.76, which is still a good saving. Now, the big difference is that if you really guys had 3 feet, but you wanted to go on the safe side and say, I have only 6 inches, because you don't want the headache condensing. Now that's the issue. For me to give you 6 inches, instead of giving you 6 tubes, I need to give you 31 tubes. So imagine as a first cost, how much more it's costing you the unit, because now I'm adding way more extra material on it. And by adding 31 tube inside your airstream, instead of condensing 12 pounds per hour, you will be condensing 40 pounds per hour. And you'll be adding 3.5 Fahrenheit heat gain, which is a monster energy loss to get the 6 inches. But sometimes in real life, you really have 6 inches. You're not exaggerating. That's what you need. So in this case, at least insulate the grid, because by insulating the grid, you're not saving on the first cost because you still need to pay 31.2, but you're saving tons of money on the run life of the unit, because instead of condensing 40 pounds per hour, you're condensing only 6 pounds per hour. So keep in mind, really important, absorption distance. Make sure you're giving an accurate distance, and try always to insulate when you can for bigger capacities. So some installation consideration to keep in mind. The first one I got asked very frequently, how far away I can be from a grid can be from the generator. So let's say you have an electric unit, a 30-pound unit, electric, how far away I can be from the grid. Rule of thumb, you always try to go 1 foot per pound for anything higher than 20 pounds. Because let's say you have 20 pounds, let's say you have 5 pounds, you don't need to go 5 feet, you can still go 20 feet. But anything, so from 0 pound to 20 pound, you can go to 20 feet, you're good. After 20 pound, ideally you want to go 1 foot per pound. So if you have 30-pound unit, try to stick to 30 feet. 40-pound unit, 40 feet. 50-pound unit, 50 feet, you're fine. And it's just up to 50 feet. So if you have 100 pounds, you can go 100 feet. If you have 150 pounds, you can go 150 feet. It's really up to 50 feet. So even if you have 200-pound unit, try to stick to 50 feet. I'm talking about atmospheric steam, so gas or electric. If you have pressurized steam, it's a different story because you're pushing the steam, you can go way, way longer. But if you are using atmospheric steam, the steam itself will start condensing through the run. So if you have a 100-feet run, you'll end up with nothing at the end of the run. You know, the steam will not make it. So always try to stick to maximum 50 feet. Keep in mind the 50 feet, that's a total length. So that includes the elbows and everything. If you have more than 10 feet, always use hard copper piping, insulated hard copper piping. Don't use flexible pipe for more than 10 feet. Always specify high limit and airflow switch to make sure that you know you have safeties. Try to use always 45-degree elbows instead of 90-degree elbows so the steam can flow easily. And the last point also I got asked a lot, so actually what I mean in this point, some engineers would ask, okay, let's say I have 2 different rooms. Can I have only 1 unit supplying the 2 different rooms? No, you can't. Actually, if you have 2 different zones in the same room, yes. So if you're shooting the humidity in the same space, that's fine. But let's say you have 2 separate rooms with 2 separate set points and you want to use only 1 generator with 2 grids. You can't do it because the problem is we cannot control where the humidity will go. So let's say you have 1 generator, 2 separate grids and 2 separate ducts. Whoever duct is has asking more humidity or has the conditions to get more humidity, that's where the humidity will go. So you can't control your set point when you split 2 different zones with 1 unit. So you always need 1 unit per zone. Also, some consideration when you're installing, when you need to install the grid and the unit, make sure you know that your piping is not bent. Make sure you have the right P trap when you need it, the S trap when you need it. Make sure you have the right pitch to go back to the unit, usually sloped by 15%. So it's really important to keep that in mind if you don't want to end up with condensation problem. So I'll take maybe another 5 minutes just to touch base on adiabatic, and then I'll leave the room for you guys to ask whatever question you want. So adiabatic, you have 2 options, even evaporative media or high pressure system. So what's an evaporative media? You have a fiberglass media here. You have water sprinkles on the top, and then the water will start going through the media. This unit will be installed inside the duct or the air handling unit, so the air will blow through the media. It will get cooled, humidified in the space. So you have here the option to have a pump to recirculate the water. So you're kind of using the same water. When you go with this option, you normally have UV lighting to make sure that the water is clean of bacteria before running it again. Or you can have the option to go direct feed, which means all the water that goes here will just go to the drain. You don't recycle any of it. Now, what's important with this option is the sequence of controls. So when, let's say, this unit is inside an air handling unit or the duct, and it's the end of the day, you want to shut down the system, you always need to shut down this unit at least 15 minutes before shutting down the fan of the air handling unit. Why? Because you want to dry off the media before you shut down the system, because if you let the media wet and there's no air to dry it off, you may develop bacteria on the media. So keep that in mind. You always need to shut the water and the unit at least 15 minutes before shutting the fan so you can dry off your media. Now, the media, it's fiberglass media. So it can run any type of water. Ideally, if your city water is not that bad, you should always run it on city water. If your water is really bad, then you need to have an RO system. But keep in mind, you cannot just supply pure RO to the fiberglass media, because fiberglass media, if you supply pure water, it will deteriorate the media way quicker. So the best solution to do it, which I'm doing one in Cleveland, Ohio right now, is to have an RO system and have a mixing valve with the RO system. So we can mix city water with RO water to get the purity from 99% pure water to 90% pure water. So you're kind of getting the water a little bit dirtier, so to preserve the media and you don't deteriorate your media. Now, another option you have with evaporative media is what we call a standalone unit. So instead of installing it inside the duct, you can have a fan directly on the unit, and then you can install it in the space. And that's where what we use mostly right now in designing data centers. And why is that? Because if you look at the data center design, you always have your crack unit blowing air, downflow, and then you have your server. So the air will go from that side. It will create a hot aisle from the other side, which go back to the crack unit. Now, if you come and you install an adiabatic humidifier right here with an integrated fan, so you can have it directly in the space, the air coming from the hot aisle will go through this evaporative unit. It will get cooled and humidified, then goes back to your crack unit. So by doing so, you're minimizing the cooling capacity of the crack unit, because now you're getting about 25% less capacity needed from the crack unit, because the unit itself is cooling down the air by evaporative process. And you don't need any humidification inside your crack unit because it's been taken care by this unit here. So that's why a lot of data centers for the past couple of years are being designed around these units, because these units don't cost much, don't need much maintenance, and it can save you a lot of energy by doing the evaporative cooling effect, for the adiabatic effect and the humidification process. But keep in mind, these at the end of the day are humidifiers. They are not AC units. So if there's no demand for humidity, these units will not operate. So you need some kind of outside the air at some point, or some kind of demand of humidification for these units to operate. So usually why it's good for data centers, because usually the hottest and the driest the air is, the more efficient you will get out of it. So let's say you're entering is at 22 Celsius, 10% relative humidity. You can go as low as 11 Celsius at the end of the day with 78% relative humidity, which is perfect. Now, if you go even here, like you have 29 degrees Celsius and 10% relative humidity, you can go as low as 16 degrees Celsius with 76% relative humidity. So the hottest, the driest the air is, the more efficient you will get out of your adiabatic. And that's exactly the reason why they use it in data centers. So the last technology we have is the high pressure system. So what's a high pressure system? You have 1,000 PSI pump here with bunch of control valves. And then this unit is connected to these rack of nozzles. It's very small nozzle with a tiny hole at the top of it where you push the water through these nozzles, it will break into droplets and get absorbed by the air. So you can have these rack of nozzles directly in the space. You can have them inside an air handling unit, or you can have them also in a different setup, like nozzles with a fan, so you can disperse quicker inside the space. So where do we use the high pressure system? Mostly what I've designed around is even printing industries, because you have high ceiling, you need heat, you need to cool down the heat from the printers, and you still need to supply humidification for the ink, for the paper. That's a great application. Wood factories, it's a great application because again, you're generating heat. You even have like the dust when you're spraying down the water, the dust will go down to the floor. So that also helps as a dust eliminator. But you can also use it and not necessarily just humidification application. Like I've designed a job with Odell for a company. I don't know if I can name the company or no, but it's a big food company, and they needed to cool down the chicken. They stored chicken in summer in places, and they needed to cool down the chicken, and that was an application that we use. So we use the high pressure system to spray water on the chicken during summer to cool them down. So you can also find application without really the need of humidity for this type of units. That's the only product in every product I showed you. That's the only product that it's a must to have an RO system. It's not an option. Even if you have really clean city water, you can never use a high pressure system on city water. You always need RO. Why? Because as I said, you have a very tiny hole in the nozzles where the water goes through. Any small debris or any small scaling will clog these nozzles. So you definitely need an RO for the high pressure system. That's the only product that should always be spec'd with RO system. And that's it for me.
Thank you very much, Ronnie. Appreciate that. Always good to catch up on the humidification stuff. I will open this up to the floor to see if anybody has questions, and we'll relay them on to you. Yes, Abraham. How do I unmute?
Do you want me to unmute?
Yeah. Now you can
Yeah.
hear me. Yeah. So, how do you address Legionella on adiabatic humidifiers? It's one of the concerns we normally have.
You're talking about the evaporative media or the high pressure
Yeah,
system?
well, it means the evaporative media one, which is
So as I said, mostly you have option. If you are recirculating the water, you always need to have like water filters and UV lights. But the big really difference in Legionella is really how you dry off your system, and that's why I said you always need to shut down the unit before shutting down the fan, so you can dry off the system at the end of the day. But the water is not warm enough to create Legionella when it's running through the unit. The Legionella will start developing if you keep the filters, the media wet, and there's no air going through the media. So mostly if you are drying off the media and using UV lights and filters, if you are doing recirculation mode, the Legionella is not a problem.
Okay.
Ali Ronnie asks, adiabatic should only be used when you want as little vapor and expect high temperatures in the room.
Well, actually, adiabatic should be used whenever there's a need for humidity and cooling at the same time. That's the ideal way to use adiabatic. Yes, because like if you don't have any humidity request, you can't use adiabatic because at the end of the day, that's a humidifier. So let's say you have an SKV, a high pressure system, and you're trying to cool down with it. But at some point, you will start saturating your air with moisture if you don't need this moisture, if you don't need the humidification side. Because at the end of the day, all these products are controlled by the humidity and not by the temperatures, because they are not in AC units. But adiabatic should be always used when you need humidification and cooling. Now, the wetted media, the one we use in data center, will not really saturate your air with humidity because you're not injecting that much. So that's why they use it in data center, because most of the time you need more cooling than humidification data center, but it still works fine.
Yeah, and I will make mention as well, like anything with like large scale, like warehousing, we've done like large printers, like adiabatic seems to be a better solution just purely on capacity. But the free cooling is an advantage as well.
Yeah. Yeah, actually, Ali, it is free cooling because it's it's the adiabatic process. So you're cooling down the air without using any energy. And actually, if you guys, I did not mention it, but both adiabatic products that I showed, the high pressure and the wetted media, the big advantage is the energy consumption. It's barely none. Like the high pressure system, you have the 1000 psi pump that I believe it's around 15-20 amps. That's it. And the wetted media, it's even way smaller pump. So you're barely using any energy and you're getting all the advantage of the free cooling and the humidification.
Perfect. All right, we'll give it 10 more seconds for, Iyad has a question. Are you able to take him off mute, Ronnie?
Yeah. Oh.
Hi.
Yes.
My question is about the piping. So I have a project where I have 2 steam generators and I am very tight in space. I'm forced to run long distance piping, exceeding the recommended rule of thumb that you mentioned. Now I'm following the manufacturer recommended distances and steam loss calculations. But what would you say about this situation where I'm significantly exceeding the rule of thumb distances? My units are small, about 18 pounds per hour units.
Talking about electric units?
Yeah.
And how significant you're exceeding? How much we're talking about, like total length?
I'm looking at what the longest one is 10-meter long, like 35 feet. Insulated tubing, copper type L, insulated 1.5 thick insulation to minimize steam loss. And like the manufacturer specification has tables to calculate the steam loss through that piping, and based on my calculation, I'm still getting the capacity that I want in the dispersion manifold. Would you have anything that you'd want to give as an input that I should pay attention to? I'm using long elbows there, but definitely exceeding your rule of thumb.
So it's 35 feet total with the elbows and everything.
Yeah, equivalent length.
I normally what I recommend, is I don't know if you're speccing with us or someone else, but whoever you're speccing with, send him a draft, like, just a quick draft of what's your horizontal run, what's your vertical run, how does it really look, and then usually we can do the math internally and make sure that you're fine. But in this case, depending on really your run, how much long vertical, how much horizontal, how much elbows you have, I would recommend to upsize the pipe, the copper piping, upsize it a little bit and upsize your unit. So instead of 18 pounds, you should go maybe 12. Well, if I'm
The
talking
next
with me,
size up.
yeah, exactly, next size up. So if I think with us would be 30 pounds, but that's what I would recommend. But it's always better to send a sketch of the run, how much, what's the distances, so we can do the math internally. You're not that bad at 35, even though it's a small capacity, but you need to double check it with whoever manufacturer you're dealing with.
Right. Would there be any solution, like any general solution to allow increased pipe runs besides like upsizing the pipe, insulating, and
No, and
minimizing elbows?
it's because it's not like the manufacturer, because it's funny sometimes I go see engineers and they tell me one of my competition, he's saying you can go like 150 feet. I'm like, it's not us or them, it's physics, it's atmospheric steam. At the end of the day, the steam will stop going because it will condense. There's nothing pushing your steam, so we cannot create a solution for that. That's physics. Like it is what it is. The only solution is even you're pushing the steam with pressurized steam or sticking to the distance, because it's not like Neptronic or any other manufacturer who can make it run longer or shorter. We're all boiling at atmospheric steam, so it's there's no miracles in here. No,
Right. Thanks.
no problem.
Ahmad asked, are there any special commissioning requirements or acceptance criteria for the humidifier system that we should be aware of? Can you perhaps elaborate a little bit on that, Ahmad, like in terms of special commissioning requirements? Are you just talking about like system startup type app, like I think I can kind of handle this one. Like that's more of a system by system basis, because the commissioning is obviously a lot different on the adiabatic to gas to electric. Most manufacturers reps do their own startup on these. So there is a pre-startup checklist available that basically allows the contractor to make sure that he's done everything in his capabilities to have a proper install. And from there, we do have, and again, it's depending on the application, but we do have a full startup and commissioning along with sign-off reports for those, which I think with any manufacturer that you have, they should have that available, because we're dealing with water and we're dealing with steam. It's something that does need to be properly commissioned. But I would follow like Neptronic would have it, but anyone would have startup documents in their O&M manuals that should be followed. I hope that helps. Yeah. All good questions. All right. If there is no more questions, I'll give it another 15 seconds. But like I said, the PDH credits will be available. They'll be assigned within the week. Oh,
Yes.
yeah. Short answer is yes. BACnet is available for all Neptronic products. And if you forget, we can order it in later on, and it's just a card that's easily adapted. So yes, that is an option. All right, great. Like I said, pH credits will be available. If you happen to be in like a boardroom where there's only one person listed, and you're beside them, feel free to reach out to myself or Anna Maria, and we'll make sure that you also get one as well if you're not part of the attendance list. But we appreciate everyone taking the time to learn about humidification. And if there is follow-up questions, you know your sales rep, or you can reach out to me. Humidification was one of the first technologies that Odell ever adapted, so we've been doing it for close to 40 years. Not me specifically, obviously, but we've been doing it for a long time. So if there's a project or an application, we've likely done it in the past. So like I said, thanks again, and feel free to reach out if there is any more follow-ups.
Thank you, guys.